So here's our first problem. We have radioactive cesium 137. Cesium 137 is radioactive, by the way. It has a half-life of 30 years. Okay, so how much cesium 137 remains if the starting amount was 100 milliliters? All right, so notice, this time when we did the calculation, we're using milliliters. So we're going to end up with milliliters if 90 years has gone by. All right, round to two places past the decimal. All right, so the first thing we have to do is let's write out our formula for radioactive material. Okay, so here we go. Whoops, let me switch this. Sorry, should have done that already. All right, so N is the amount that remains, and that's going to equal N sub 0, which is the initial amount, times 1/2, and 1/2 is to the power of T, the time that's gone by, divided by T 1/2, which is, of course, the half-life. All right, so this one, we can put all the numbers in here. So this is equal to the starting amount, which was 100 milliliters. All right, so 100 milliliters. All right, and then it's going to be 1/2 raised to the power of, all right, so the amount of time that has gone by is 90 years. Right, so it's going to be 90 divided by the half-life, which is 30 years. All right, so, that's obviously, we can simplify this quite a bit. 100 milliliters, remember, it's still going to be in milliliters, times 1/2 raised to the third power. Right, so 1/2 raised to the third power, of course, is just 8. And here, so you can do this in your calculator as well. Here, so here we go. So so 0.5. Let's see, how do you raise it? Oh, here it is. 0.5 raised to the third power. All right, and so that's going to be 1/8. And so then you multiply that times 100, and see it says to round it to two places past the decimal. All right, so of course times 100, that's pretty easy because you started with 100 milliliters. So it's going to be, well, we'll just round it to one place. Well, we'll round it to 2. So it's going to be 12.50, even though there's no more digits left. It's just because we started with 100 milliliters. All right, so the answer is 12.50. All right, so this is 12.50 milliliters. All right, and remember, in Blackboard, when you do this, you're just going to put, like, if you're asked for a numerical answer, you just put the number. All right, so all right, let's do our next problem. I'll set it up. All right, so we have a very similar problem. So we have cesium 137. Again, it has, because it's radioactive, it has a half. We measured the half-life. The half-life happens to be 30 years. All right. So how much cesium 137 remains if the starting amount? So this time it's the starting amount is 750 grams, and now we only have 45 years going by. So remember the last problem, the one we just did a moment ago, we had 90 years go by. And of course 30 goes into 90 3 times. This time it doesn't go in. 30 doesn't go in exactly into 45, but that's okay. We can still solve this problem, right? It's the same. N is what we're looking for, times N sub 0 times 1/2 raised to the T over T 1/2. It's just the way we write the half-life is to the T 1/2. All right, so now we're going to put the numbers in. So the starting amount is 750 grams. 750 grams. All right, so N is going to our value, that's N0, and so N is going to also be in grams. All right, and so this is going to be 1 half or 0.5 raised to the, okay, so t is the amount of time that goes by. So that's going to be our 45 years. So it's going to be 45 divided by 30. All right, so you just have to do 45 divided by 30. All right, here, let's get this calculator going. Oops, let me move it over a little bit so you can see this. All right, so you just do 40. Remember, do what's, oh, I should put parentheses here. I'm trying to put parentheses right here. So you should put parentheses around this. It's hard to draw. That's a 30, by the way. That's 30 years. So 45, the years part cancels. All right, and so 45 divided by 30, all right, is equal to, so it's 1.5. So 1 half to the 1.5. All right, so here we go. So it's going to be 0.5. So you got to know how to raise something to a power in your calculator. So 1 half, which is 0.5. So this particular one, you hit the x to the y, and y, of course, is 1.5. Right? So that's, of course, what 45 divided by 30 is. So we multiply this fraction, which is approximately 35%. So roughly 35% of this 750 is going to be left over. Well, let's get the exact amount, and we're going to, it says here, round to 2 places past the decimal. So we're going to multiply that times 750, right? Because that's our starting amount. And so that's the amount, all right? So we started with 750. So we're going to round it to 2 places past the decimal. So it's 265.17, right? Because the third digit, since we're rounding to 2 digits past the decimal, the third digit is 5 or greater. So this would be, here, let's just write this, 265. So it's going to be 265.17 grams. Here, let me double check to make sure I remembered that correctly. 265.17, right? So that's rounded to, so when we say 2 places past the decimal, that's correctly rounded to 2 places past the decimal. All right, very nice. Let's do our next problem. All right, so this is a slightly different type of problem as we're going to see. So we have uranium-238, which has a half-life of 4.5 billion years. And of course, we write that mathematically as 4.5 times 10 to the 9th years. A 1.125 billion year old rock is found to have 420.45 grams of its original uranium-235, right, remaining. Okay, so this is the amount remaining. So that's a little different than the problems that we've had so far. And it says, what is the original amount? Remember, when we write this equation, okay, so look, so N, let's see, why is this not working? So N, hold on, get my, all right, so anyhow, let's try it one more time. Oh, come on. So N, let's pause this. All right, so with this particular problem, it's the same formula, but see, this time, what was the original amount? Really, what we're looking for is n sub 0, right? We're actually trying to solve this for n sub 0. So, what we're gonna have to do is put this stuff on the other side of the equation, right? And so it just stays the same. It just goes in the denominator, right? All we're going to do is divide both sides, right? So we're going to divide both sides by 1 half to the t over t 1 half. Right? That should be in parentheses too. And so we divide that by 1/2 to the, it's going to look a lot better than this in just a second, T over T 1/2. No, that's just, of course, the half-life. And then, of course, this 1/2, this cancels this. And so that gives us n sub 0, right? That's what we're looking for. That's a 0, sorry. N sub 0 is equal to, so it's going to be n over, so it's it's the same. It's just now this is in the denominator. So it's T divided by T 1/2. 1/2. All right, so here we go. All right, let's put the numbers in. All right, so now n is the amount that's remaining, right? So it's 420.45. Right, so 420.45, 420.45 grams. So that'll be, that'll tell us that n sub 0 is also in grams. And we divided by, so 1/2, of course, is just 0.5, but we have to raise the 0.5 to the, so it's, now we can put the billions, but I'm going to show you something that the billion, it's the amount of time that has gone by divided by the half-life. All right, so this is the amount of time that has gone by because it's a 1 point. So it's going to be 1.125, and for the billion, I'll just put e to the 9th divided by 4.5 e to the 9th. And then what's nice is the e to the 9th just simply cancels. All right, so it becomes much simpler. You can put the times 10 to the 9th; they'll just cancel. That's perfectly fine. So that's that. 420.45, and of course the answer is in grams, divided by, so it's going to be 0.5, and it's going to be so it's 1.125 divided by 4.5, right? Again, that's 4.5. That's supposed to be a 5. That doesn't quite look like a 5. All right, so let me get my calculator out and we'll set this up. Here, let's see, where's the calculator? There we go. Oops, move it over a little bit. All right, so we're doing this problem right here. Here, let's clear this. All right, so we got to do the 1.125 divided by 4.5. 4.5. All right, so we got that. All right, so it's 0.25. So we just say 0.5 raised to the 0.25. All right, there we go. So 0.5 raised to the, is that, remember, that's in the denominator. All right, so we're going to take 420.45, so 420.45 divided by, let's see, does this thing remember the last thing that we just did? Oh, I should have saved it. Hold on. All right, so what I just did is I just stored this 0.5 raised to the 0.25. All right, so that's now in storage. So it's 420.45 divided by, and you just have to hit this recall button. See, there's the number, but that's in the denominator, and so that's the amount that's the amount that you started with. So rounding it to two places past the decimal, it would be just 500.00. Right, so let's put 500. The answer is 500.00 grams. All right. So that's a slightly different way. Here, let me show the calculator one more time. And again, if you had put the times 10 to the 9th here and times 10 to the 9th there, the times 10 to the 9th would have canceled.